Hello and welcome to the first video for Chapter 2 of my AP Computer Science A coding videos. Chapter 2 is about methods and classes, and this first lesson is going to be our introduction to methods in Java. And we're going to take a look at a lot of details about how methods are set up, and so let's dive into it. So first up, our first key point is that methods are only defined inside of classes. So when we are writing methods, methods can only go within the curly brace set of a class definition. That means we cannot put a method outside of a class. So I'm not allowed to write a method here. So I can't say public static void say hello. I can't write a method here. So that would be an invalid syntax because it's not inside of a class. So if I could take this, I could cut it, and I could go paste it here. This would be valid because this method is being declared inside of the curly brace block of the class. And you cannot define methods inside of other methods. So this is also invalid. So really methods can only go in one place, and that is inside of a class definition. As we're going to see a little bit later on, you can invoke methods from other files altogether. But again, it's still following the same rules. This method is inside of a class definition. It's a totally different file, and we're going to take a look at that, but that is kind of the key point about where methods go. Now, let's talk about probably one of the most important ways to think about and describe methods, and that's looking at their method signature. Sometimes you call it a method header. This describes the first line of a method. So, for example, main method, this is the main method signature. This is the signature for my say hello method. And let's break down what all of this means. So the first one I actually get to is the return type, and that is right here. So the return type of this method is void. So void means that the method does not compute and give back an answer. Other return types could be a mathematical thing. So let's say we make a method here. It's going to return a double, and we're going to calculate the slope. So we'll do slope. And slope, unfortunately, takes a couple data points here. So let me punch in my data points. And so when you do slope, you kind of expect that there's going to be an answer back. And so I'm going to do this in one line. The idea is that a method that is non-void will give you some data back, but that is the return type of a method. So the next part is just the identifier or the name of the method. So in this example here, the identifier is say hello. On this one, the identifier is slope calc. And you want to pick an identifier that describes the method well, because the idea is that you're trying to make a descriptive name that doesn't require a whole lot of comments to describe. Then we have the parameters. The parameters are the things that are listed inside of the parentheses of the method name, and they specify the inputs into a method. Trying to make a little fancy looking arrow here so that it, looks like an arrow pointing at things. So this is our parameters. So now this one has no parameters, so there's nothing inside of that set of parentheses. But this one does actually have a lot of parameters. And so our parameters are over here. And it has many. We've got double x1 is a parameter, double y1 is a parameter, double x2 is a parameter, and double y2 is a parameter. So parameters are the inputs to a method. So you can have as many parameters as you like. You can have no parameters, but parameters define what is going into this method. Then the other thing that we want to point out is that methods can have other modifiers that describe their usage, how you might view them. So here we have public and static as other modifiers. And I'm not going to kind of add them to this little diagram because there can be any number, and I don't want to draw too much attention to them. And we'll look at what public and static influence when we actually start talking about calling these methods, which I think is what we'll talk about right now. So when we're calling methods, all you have to do to call a method is to just say the name of the method with parentheses and the semicolon. So we know that our programs start in main. And so main is going to start here, and then it's going to hit the say hello method. And so it's going to jump down here and run the code here. And then when it's finished, it's going to come back to main method. So let's just do and then we'll have another one out here. And when we run this, what we're going to see is the program is going to start here, and it's going to say first line of text. Then it's going to jump down to say hello. It's going to start here. It's going to run hi. Then once this method completes, it comes back to where we came from, and then we continue running code through that. So I can hit compile and run, and we can see that it did just that. That it ran this line, hit the method, did the code of the method, and came back. So calling a method, invoking a method, whatever we want to call running it, if the method is in the same class as where the other method that we're running it from, all we have to do is just say the name of the method. So in this case, I say hello, and it will run that method. So if we're in the same class, we don't have to do anything special. As we start to look at objects, we're going to see methods look a little bit different if you're running them off of an object. A very common example, oops, not a string, is like when we were using scanner. Oops. That autocomplete sometimes just, yeah, it puts it in some weird spaces. So you have to be careful about that if you have a lot of comments at the top of your program here. So like when I'm using a method off of reader and I say next line, that's running a method. So this is still calling a method. It's calling the method called nextLine from the object reader. And as we continue through this chapter, we're going to see this in a little bit more detail, and this will make a lot more sense. But I think the key point that you can take away from this is because we are not in the same code file that our scanner was created in, we can't just say the name of the method. We actually have to preface it with where do we find this method. We're going to find it from this reader object of scanner and then run the next line command. Here, this say hello, we're in the same file, so we're able just to say hello. Now, I did create an example over here that's in a totally different file. And so this method is called average. And we're not in the same file. So I wouldn't be able to just refer to that method. So like I can't just say average and then send it in some numbers. You can see that the error here is undefined. It doesn't know what average is. So if I wanted to refer to a static method in another class, I just have to say the name of the class, which this name is a little bit weird, lesson 01b.other file. I just have to say the name of the class. With the correct capitalization. And now I can access it. So when I say let the name of the class dot average, I'm able to run that method. And this isn't the first time we've seen something like this. So you can see that the average of these was, in fact, 5. When we were using the math library, we did this. We're running the square root method off of the math file. We didn't write the math file, but we can look up what methods are inside of it. And so we're saying access the math code file, wherever it is, and run the method called square root with an input of 64. So when you're calling a method, if you're inside of the same class, you can just say the name of the method. If you're not, there's going to be 2 ways that we're really going to see. Static methods are going to be invoked like this, where you say the name of the file, and then non-static methods are going to be where you refer to the name of the object. That will be a little bit clearer by the 3rd lesson. But essentially, if you're outside of the current file, you have to do something else to access it. Now, the other thing that kind of ties in with calling or running methods, and we've kind of seen this in some of these examples here, is what do they return? What do we get back from a method? So methods, when we're talking about these headers, have different return types, and those return types influence the purpose of the method and what we would, the context that we would use the method in. So let's take a look at like the 2 categories. And those categories are void methods and non-void methods. So methods can return any data type. They can only return one thing, but that thing can be any data type, which includes arrays or custom data types or custom objects. And so when we're thinking about returning stuff, a void method usually just does some commands. So in this example here, it's just printing stuff out. Say hello is just printing out hi. It's not doing some computations. It's not opening a file and reading stuff. It's just running commands and doing a thing. But methods that return stuff, you can think of them as methods that have like more of a computational purpose. And so this example of slope calc, maybe I don't want to have to sit there and type this entire formula out every time I need a slope. Maybe I just want to do a quicker way of accessing it. So if I wanted to call my slope calc, I can just refer to this method and it's going to do all the math for it, and it will substitute back into this place whatever answer it happens to be. So I picked 0, 0 going to 1, 4. So that should be a slope of 4 because we go over 1 and up 4. And so we got a slope of 4. You could store it. You don't have to print it out. So we could maybe make a variable here, and like it'll be called like slope answer, and then we ran so I'm making variables that maybe I read from a file or I got from the user. So also just kind of pointing out this little shorthand that if they're all the same data type, you can declare and assign in one line just to make it shorter and more compact. So like we could invoke the method with actual us specifying the numbers. We can invoke the method with using variables to plug in those values. So in this slope calc, it's going to get these values from here. So it's going to use 0 for point x1, it's going to use 0 for point y1, it's going to use 1 for point x2, and it's going to use 4 for point y2. And that's an important thing to kind of look at about how the parameters work. It knows which thing is going to be plugged into which variable here from the order that you list them when you're calling the method. So the fact that this is 0, 0, 1, 4 does matter because that's going to be the order that x1 gets its value, y1 gets its value, x2 gets its value, and y2 gets its value. So these variables will get their values from the order that we put them in. And you can also notice that it will convert, it will cast. So like I put an integer here, and it was smart enough to realize that an integer can cast to a double. Now, in some cases, you have to watch out because if you have integers as your expected input, it's not going to automatically cast an integer into, it's not going to cast a double into an int because there's a risk of a loss of data. So it will not convert this double. And even if you look at the error, you can see the method average expects int, 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 but I passed in the arguments double, int, int. So it's not happy about that. Also looking at returning values. So when you have a method that's trying to return something, so in this case we have slope calc, the return command ends the method and it's going to substitute back this value. So whenever we hit return, this finishes and slope calc converts this from this call into some number. And you can have, if you have an if statement, you can have different returns. You can do your computations on this return line. You can do the computations ahead of time. So let's just make a method here that returns a string. So in this one, we could do the computations ahead of the time. So I could say like greeting equals hello, comma, plus name, plus an exclamation mark. And so it's going to take this parameter of name, it's going to insert it here, it's going to create this variable called greeting, and then we could return it like that. We don't have to do the entire computation on the same line. We can split it up over a couple lines if we want. But either way, this return command ends the method. You cannot have any more code after it because the return ends the method. This code is unreachable, and so that's going to cause an error. So your return finishes your method, and then brings your data back to here. Now, I will point out that with these void type methods, you probably do not want to run a void type method inside of like a print statement or an assignment statement, because it's not returning anything. So if I did something like this, where say hello is trying to run, but say hello doesn't return anything. So the print line's mad because we're trying to print void. We're trying to print nothing because say hello doesn't return anything. So kind of keep that in mind, that when you're using void methods, you typically do not put them inside of like another statement. You're not going to put them in a print line. You're not going to want to assign a variable to a void, because a void method just does some things. So when I run say hello, it's doing some things. It's printing some stuff out. I guess the other thing to say about returning values is just be mindful of the data types. There's a lot of integer division issues you can run into, and we'll see that as we kind of practice stuff through. So we've really just talked a little bit about running methods, getting answers back from them, but there's definitely, I think, a bit of an elephant in the room of these keywords of static and public. And so I do want to mention what they do. We're not going to see public a whole lot, because public defines the visibility of a method, and for the purposes of the AP exam, all methods are going to be public. But what public actually does is it lets methods be hidden. So like maybe you have some computations that you don't need to make visible to other parts of your program, so you can make a method private. And if you make a method private, it can't be accessed, but it also won't show up on the IntelliSense. So when I start typing out like this and I push dot, and it tries to pull up the methods that it finds from this file, if this is private, it won't show up. So as you start making more complex things, private is a good way to hide methods that you don't need to see. And we can even see what happens. So like this runs, but if I go over here and I switch this to private, and we jump over here and we hit save to compile it or get it to check the updates, we can see that average no longer works. And it recognizes that average does exist, but it's just not visible. And so that's what private versus public does. And for the purposes of the AP exam, we're just going to kind of say that all methods need to be public, because that's how they structure the exam. The static modifier is a little bit more interesting and something that we are actually going to care a lot about. I think the broad definition you can say of static is that it allows a method to be run when the object is not instantiated yet. And again, we haven't covered objects, so that's not going to make a whole lot of sense. But I think another definition that makes some sense is a static method can only call other static methods. And that might help for us to think about it right now, that when we're starting inside of main method, because main is a static method for the reasons of the fact that the class hasn't been instantiated yet, main can only call other static methods. So here you can see that this one has the keyword static, but if I take out that keyword static, I can no longer refer to it because I cannot make a static reference to a non-static method. So static is going to play a large role, and it plays a really interesting role. It's kind of how you would make like global variables. It lets you make methods that can be accessed from almost any part of the program. And static is interesting, but it does provide a little bit of confusion right now, because the true meaning is that like static lets a method run without the needing to have concrete data or the instantiated object with it. Okay, so something a little bit more normal. That methods have their own memory space, and that kind of is part of the idea that a variable scope. So methods do not see variables in other methods. And actually, it gets color coded in Eclipse pretty interestingly. Like if what's called a local variable gets colored brown in kind of this default light here. So let's see an example. Down here in greet user, we have the variable name, which was one of the parameters, and we have the variable called greeting. So that means this method called say hello would not be able to access this variable called greeting, because greeting is a variable that is local to this method greet user. A big broad definition: variables only exist in the curly brace set that they're defined in. So this variable greeting will only exist inside this method greet user. Same problem here. Now, what's kind of interesting is if I have a variable declared here in main, that's x is 10, this method called say hello cannot see this at all, because each method has its own memory space. This variable int x10 only exists inside the curly brace set it was defined in. So I would not be able to see that over here. So if I try to do this, you can see that it does not recognize what x is. X cannot be resolved to a variable because x exists over here. But what that means is I could have an x over here, and this x has no idea about the existence of this x, so I just updated the print lines so we can see them a little bit better. So when we run say hello up here, it's going to have no knowledge of that x. So this is from say hello, x equals 20, because over here, x equaled 20. And then when we jump back to main, x is 10. So variables only exist here, and this x has no interaction with this x. Now, touching on a topic we will get to a little bit later, we can define the variable up here in the class, and I'm not going to really spend a lot of time looking at this. This is what's known as an instance variable, and it gets shaded blue instead of that brown color, and that means that this variable x exists in this curly brace set. So it's going to exist throughout the entire class, which means that it's going to be, well, it needs to be static because of what I said earlier. Static method can only interact with other static things. So this x is going to be the same as this x. And we can see that that is, they're both 10. So we're going to dive into that a little bit more later, but a variable declared up here in the class level can be seen and used and interacted with by all the methods in that class. And that leads us to the last point, and that is that when we're talking about variables, if we want to send information to another method, One of the primary ways that we have to do that is through parameters. So if I wanted a method here, let's just say, let's make a method here called like print number. And it takes a parameter, z, which is an integer. And we're going to add 15 to it. So the idea is that we're going to add 15 to z, we're going to print it out, and then we're going to run that method here. Forgot my static. And we're going to see if the changes that we make here have any impact on the variable up here inside of main. So main method's going to run, and it's going to create a variable called x and set it equal to 20. We're going to print that 20 out. Then we're going to take and pass that 20 into this method called print number. So this x then becomes 20, and then z gets assigned a value of 20. Z becomes 35. We print out 35. This completes. And then we come back here and we wonder, what is x going to be? So x is going to not change because when we pass a parameter, it makes a copy of it, and that's called passing by value. So when I say int x is 20, it's not actually linking x to here. It's just substituting the number 20 in and then running. So then basically when this runs, z gets set to the number 20. Z doesn't know that this 20 came from x up here. It just sees that number 20. So if you modify it down here, it's not going to modify it where it came from. And that's for primitives, because there's going to be some slight differences in how objects work. Objects still technically pass by value because it's a memory address, but changes to that object will still impact it. That's getting ahead of ourselves, so we're not going to worry too much about that, but I will point out that be cognizant of there's a difference in how objects behave as parameters and how primitives behave as parameters. Primitives basically copy themselves, and if you change a primitive down here, it's not going to impact it where it came from. And so I know that is a lot to digest, but methods are going to play a huge role in almost everything we do, and we're going to see these concepts be repeated and have a chance to experiment with them pretty much throughout this whole chapter and through many of the other chapters, where our knowledge of methods is going to expand as we see if statements, and then we're going to start like passing objects as parameters, returning arrays. So methods are going to continue to become more and more powerful as we learn some more components to the language. So thank you for watching, and I will make this code available in the comments of the video. I will probably clean up some of these comments a little bit so it's a little bit easier to follow. But thank you for watching, and practice with some methods.